A very good morning to everyone. Let's begin with today's class. Today we are planning to do electron transport part 1. But before beginning with the topic, let us have a small introduction about myself and Unacademy. And as we say in the starting, let's crack CSIR UGC together. I'm your educator Farida Bandookwala and I am pursuing my PhD School of Biotechnology KVV. I've done my BSc, MSc, MPhil in Biotechnology. I've qualified MPSLET examination and I have a teaching experience of 10 years. If you are saying Unacademy, what are you going to get with Unacademy? What all are the benefits of using Unacademy for the preparation of CSIR UGC NET? You'll be getting daily life classes so that you can always have that motivation that I have to do class tomorrow and all. So you will have daily classes with Unacademy. In those daily live classes, most importantly, daily live class, you can ask your doubts and queries with the faculty member. So this is the benefit of daily life class, and you get structured courses. So as the CSIR syllabus is very vast, you need 14 units. The syllabus is very much structured so that you don't have to stress out about the time management. Faculty members they design the course in such a way that you can be able to complete that course in a limited period of time. And there are live tests and quizzes, and I always say for qualifying any kind of examination, you need to evaluate yourself that how much you have learned so far. So that can also be done with Unacademy as there are live tests and quizzes, and then you will have unlimited access for whichever category you are opting for. So here, if you are opting for CSIR UGC, you will have unlimited access to all the videos which are done in this category by the faculty members. Like if one video of one topic is there by one faculty, you will get multiple faculties which have taught this topic. So whichever you find more comfortable can be used by you or can be of benefit to you. This is about Unacademy. Then Unacademy conducts free live classes. So where these free live classes we do is first of all live. So we know what is live classes very well. Uh, that you can ask your doubts and queries at that particular point of time. Another thing about free live classes. The first type of free live class we do on YouTube. So YouTube is the place where we do the free live class, and the another place where we do free live class is a special class that is on the app. That is on the app of Unacademy Learning app. So what you need to do for getting these special live classes, as you know that for you have to follow that channel and you will be getting the notification of the upcoming videos. If you are doing your special class on the app, so you need to download the app from Play Store, and then you need to select one category for which you are preparing for. So you are preparing for CSIR UGC. So you will be opting this, and then your account, and you'll be following certain faculty members. So if you're following me, you'll be getting the updates of all the upcoming videos which I'll be doing. So you can search my profile over there in the Farida Bandookwala, and there are options for messages and everything. If you have a doubt or query or you want to read a particular topic, you can write in the personal chat box also. And there is this plus subscription, and what is this plus subscription? All the 13 units will be explained in a very systematic manner in this class platform, and these 13 units you can complete in a restricted time span. And for all the upcoming exams there are crash courses which are conducted by faculty, short term courses are conducted, test series are conducted, marathon of tests is conducted. So all these benefits you can get with the Unacademy. The another thing that is beneficial, that can be beneficial at this point of time to you, is to use my subscription code, that is FB01. If you are using my subscription code or referral code FB01, you will be getting a 10% discount in the amount of subscription. So do not forget to use my referral code, that is FB01, for getting a 10% discount. So the charge which is there for the subscription is very pocket friendly. It's 10,000 for 12 months and 15,000 for 4 months. You can go for 12-month or 24 monthly program. It can be of great help. Now this was a little about Unacademy. Let us move towards the topic, that is electron transport chain. So what is the full form of ETC? It is electron transport chain, and this we'll be doing in parts. So this is the part 1, and this electron transport chain is also called as biological oxidation. And as this is the first part of electron transport chain, this is the first part of biological oxidation. So what all things we are going to see in this, the overview of the topic, that what you should know is oxidation. You should know what is oxidation. You should know what is reduction. You should know what is redox reaction. You should know what is pair. You should know or reduction pair. You should know reduction potential, and the site of electron transport chain. Like in last class we did Krebs cycle, so we did that Krebs cycle. It occurs in the mitochondria. Here the place of electron transport chain is, site of electron transport chain is of various complexes and mitochondria. Then we will also read that what are the various complexes of electron transport chain. So this is the overview that what we are going to the class. So let us begin with the topic. What is electron transport chain actually? So it is transfer of oxygen from NAD and NADP to final receptor. Final receptor. Then what other thing can be said if this is the basic thing in electron transport? What other thing? Pumping of hydrogen ion into the intermembrane space is electron transport. Pumping of hydrogen ions into intermembrane space is electron transport chain. What else about an electron transport chain? We are going to understand about the chemical hypothesis in the upcoming classes. We are going to read about oxidative phosphorylation. We are going to read about the inhibitors of electron transport chain. We are going to uncouplers, and we are going to see oxidation of foodstuffs. So these all things we are going to read in the upcoming classes. But in today's class, as this is part 1 of biological oxidation, till here we'll be seeing. Now let us see that carbohydrates, proteins and lipids, they get converted. Lipids, um, lipids get converted gets converted into monosaccharides, then amino acids, and then fatty acids. So fatty acids, lipids for fatty acids, proteins for amino acids, and carb monosaccharides. So they get converted into the simpler form, and this is the first step of metabolism. This is the first step of metabolism. Now what else occurs over here? They enter into PCA cycle. They enter cycle by acetyl CoA or through intermediates. intermediates. Now, the second step is intermediates, they are converted into carbohydrates. Intermediates into carbon dioxide. And the intermediates into carbohydrates, they give rise to NADH, FADH plus protons. And then they enter electron transport, enter into and gives ATP. So NADH is responsible for giving 2.5 ATP and FADH2 responsible for giving 1.5 ATP. So this whole thing is actually third step of metabolism. Third step of metabolism called as cellular respiration. This is cellular respiration. And this is what we are going to read, that how the energy is actually produced. Now, as I told you, we need to know what is oxidation. So what is oxidation? Oxidation is loss of electrons. Oxidation, loss of electrons. Reduction is gain of electron. The 2 positive form of iron will get converted into 3 positive, or ferrous form is converted into ferric form by removal of 1 electron, and if removal of 1 electron is occurring, that means that iron is oxidized. So the process is oxidation. And vice versa, if it is gaining 1 electron and ferric form is getting converted into ferrous form, and this process is called as reduction, and the iron is now called as reduced. So reduced and oxidized, these are the terms that you should know. Now if we are saying iron and another thing which is in its equivalent in the process of oxidation and reduction for ferrous to ferric form, we need to know what other things are in combination. NAD is for NADH, FMN is for FMNH2, FAD is for FADH2. So these are the things. Now the substance which actually exists in oxidized and reduced state both are called as redox pairs. So these things are called as redox pairs. These things are the redox pairs. Compounds which exists in the reduced and oxidized state are called as redox pairs. So substance which exists in oxidized and reduced state called as redox pair. Right. So these are the basics we have seen, that I was telling you that we need to know the basics. Now some more things which we actually need to read is redox potential or electron transfer potential. Redox potential or electron transfer. Right. So what is redox potential or what is electron transport potential? So it is the tendency of redox pair to gain or lose electron, which can be expressed quantitatively. It's called as redox potential. So it's a kind of quantitative thing, redox potential. It is the tendency of redox pair to gain or lose electron can be expressed quantitatively, called as redox potential. So this is the definition. So how we are going to understand the redox potential of various substances in our body. So the things which actually exist in the air, we have to talk about them. So redox potential. Redox potential. The redox potential of NAD is NADH is minus 0.32. The redox potential of FMNH2 is minus 0.0. The redox potential of FAD is FADH2 is 0. The redox potential of CoQ, coenzyme Q, is plus 0.10. The redox potential of cytochrome C is plus 0.5. The redox potential of cytochrome AA3 is plus 0.9. The redox potential of half water is plus 0.8. So can you see some of them are in negative and some of them are in positive. So what do this positive and negative actually indicate? So we have seen some of them are in positive and some of them are in negative. So negative sign, it indicates the negative redox potential, that is they have more tendency to lose electron as compared to the positive ion. And if less hydrogen sign is there, then it is or if in the compound there is less amount of proton is there, it is represented as negative. If more hydrogen is there, then it is represented as positive redox potential. So in this, the ones which are in negative, they will lose electron, and the one which are in positive, they are going to gain electron. The ones which are in the negative, they are going to, what they are going to do, they are going to lose electron. They are going to lose electron, and these which are in positive, they are going to gain electron. So electrons are transferred from negative redox potential to the positive redox potential. The electrons will move from negative redox potential to the positive redox potential. This will be the path of electron. Now the site of electron transport chain, like we said in the overview, that we are going to talk about the site of electron transport chain. So site of electron transport chain, there we wrote mitochondria. Now the actual place is inner mitochondrial membrane. Inner mitochondrial membrane. And on this inner mitochondrial membrane, enzymes are arranged. The enzymes are arranged in a various manner. If this is your outer membrane, the inner membrane is the outer membrane, and this is the inner membrane. Right? And This is the intermembrane space. Intermembrane. So this we need to know. Now on the on the inner mitochondrial membrane, they are arranged in sequence. So here the complex, it is arranged in a sequence. The sequence is NAD, coenzyme Q, cytochrome B, C1, C, AA3, water. The sequence is this. This is the sequence in which it is arranged. So electrons are transferred from NAD to downstream and further water is formed. So electron will go from one to another, one to another, one to another, and lastly water will be formed. This will be the path of electron to travel. So if you can remember this sequence also, it will be very easy for you to attend the question. Now the complexes. We are going to talk about the complexes. The complexes which are involved. So complex 1. Complexes involved in it. Complex 1, it is NADH, coenzyme Q, oxido reductase, and it has FMN as prosthetic group. So don't worry, I'm going to draw the whole chain also, but here first in a very simpler manner I'm going to tell you the whole story. Prosthetic group and iron, sulfur. So FMN as a prosthetic group and iron as a protein. So the sequence of transfer of electron. Sequence of transfer would be NADH plus H positive go to FMN, FMNH2, then it is going to go to iron sulfur complex. So this is the oxidized and reduced ubiquinone, and ubiquinone going to get converted into hormone, and which is going to get converted into quinone. So this process is going to get give rise to quinone in this step. Now talking about the complex number 2. Complex number. So complex number 2 is made up of succinyl dehydrogenase complex, dehydrogenase complex, and it is also called as succinate coenzyme Q reductase. And it contains FAD. It contains FAD as prosthetic group. It contains FAD as prosthetic group, and it also contains iron sulfur protein. Also contains iron sulfur. So the sequence will be like this: succinate to FAD, FAD, iron sulfur to coenzyme. 2 to QH2. Here there will be transfer of electrons. So this was about your complex 2. Then talking about complex, what happens over here is coenzyme Q, cytochrome C oxidoreductase. This is the name of the complex. Cytochrome B, cytochrome 1, and iron, form of ferrous and ferric form. That is the oxidized and reduced. And this sequence of electron transfer, as we do in every of electron transfer, sequence of electron transfer is going coenzyme Q, iron sulfur, cytochrome 1, cytochrome 1. This is the sequence of electron transfer. Then talking about the complex 4, here the cytochrome oxidase is there, and it contains iron in oxidized and reduced state, and it contains copper in oxidized and reduced state. Right? And the sequence of electron transfer we are going to see. Sequence of electron transfer. So the sequence of electron transfer, cytochrome, cytochrome AA3, half of the water. This is the sequence of electron transport in this. Then there is a fourth complex also. Our fourth complex we have seen, fifth complex. Sorry. Complex fifth. Complex fifth is ATP synthase. Complex fifth is ATP synthase. Now, before moving to the actual process, one more thing I would like. Substrate for NADH. Or that is glyceraldehyde 3-phosphate. Glyceraldehyde phosphate. Pyruvate is isocitrate. It is alpha ketoglutarate. Malate. Beta hydroxy CoAQ. Hydroxy acyl coenzyme A. So these are the substrate for NADH, and we need to know about the substrate of FADH2 as well. So substrate for FADH2 will be succinate, fatty acyl CoA, then it is mitochondrial glyceraldehyde or glycerol 3-phosphate. Mitochondrial glycerol phosphate are the substrates. These are the substrates. Now we are going to see the actual diagram of electron transport chain, that how it is drawn and how the electrons they jump from one place to another. Now this is our next task to make that thing. Now I'll be writing over here diagram of electron transport diagram. Transport. So we have to make the whole thing. Which we go like this. Now we are going to make the complexes. And lastly, fifth one also effect of it. Fine, we have drawn the. Now we need to write the flow. Our complex number one, and it is made up of iron sulfur, and the of electron transport from NADH, NADH plus H. Electron will transfer from here. Complex, there will be FMN. FMN will give NH2. Then it is going to transfer iron sulfur. Now the electron, it is not going directly to complex. There will be enzyme Q. So the electron from iron sulfur complex is the coenzyme Q, and from coenzyme Q, electron is complex. Talking about, but before that we'll be talking about complex. So complex number two, it gets its electron succeed, and here in this it is going to be FH2, and then it is the electron to iron sulfur. And here also it will be transferred to CoQ, and from CoQ it is going to the third complex. Now talking about the third complex, that it is made up of cytochrome B. From cytochrome 1, and from cytochrome it is going to cytochrome C. Cytochrome, and in this place there will be removal of 4 hydrogen ion in this place, and there will be liberation of energy also. uh, there will be liberation of N. So 4 hydrogen are released over here from cytochrome C. The fourth complex, and this fourth complex is made up of iron, copper, cytochrome A complex. And in this case again there will be addition of 4 hydrogen ions. I'll just up over here this thing that it cannot create much. Yeah. So here also there will be liberation of hydrogen. Hydrogen ions are liberated and electron will go half of the uh, oxygen and then it will be converted into water. The final acceptor of electron is oxygen. So we'll write over final acceptor of electron. Final of electron. And this is your fifth complex, right? So this is how the whole process it occurs. Now the energy which I was telling you liberated. So here there will be liberation of 12 kilocalorie energy pump the on to pump the hydrogen. Here there will be liberation of 10 kilocalorie and like this it occurs. So 10 hydrogen ions are pumped out in inner mitochondrial membrane, inner or intermembranes better intermembrane space. This is how the whole thing occurs. So it is assisted with liberation of energy. Right now we'll be doing the gist of the whole thing. So the gist is complex one. Complex one is made up of NH, Q, oxidoreductase. Complex 2, it consists of succinate, dehydrogenase, or succinate reductase. Then complex 3 is made of coenzyme Q, cytochrome C, reductase. Consists of cytochrome oxidase. And the two intermediary acceptor that is the mobile electron carrier, and its place is not fixed. Place not fixed. Then another is cytochrome C, is also the mobile electron carrier. Mobile carrier. So like this, we have completed our electron transport chain. I hope you will have understood in a systematic manner. I'll do a very quick revision of the same. So electron transport chain, part 1 is also called as biological oxidation, part 1. So what all we are going to see that first of all we saw that it is transfer of oxygen from NAD and NAD to the final acceptor, pumping of hydrogen into the intermitochondrial space. Carbohydrate, proteins, and lipids they get converted into their simpler form. Is the first step of the oxidation. Then they enter into TC cycle by acetyl CoA or through various other intermediates, and then it is carbon dioxide and TC. And in the third place, the NADH and FADH2, which were produced, they now are used for the generation of ATP. After that, oxidation is loss of electron, reduction is gain of electron. Then we have seen example of redox pairs, So the substance which actually exist in reduced as well as oxidized state, they are called as redox pairs. After redox pair, we have seen what is redox potential. Whenever we can calculate the ability of a particular thing to whether it is going to accept the electron or it is called as redox potential. So the negative charge, they have got the um, negative redox potential, that now they can lose electron, and those with positives, they have got the capability to accept the electrons. And this is the actual sequence of transport of electron in the electron transport chain. That is, it is going from NAD to coenzyme Q to cytochrome B, cytochrome B to cytochrome C1, cytochrome C, then cytochrome AA3, and finally it is going to get converted into water. And then we have seen about the complexes. The complex number 1 is called as NADH, coenzyme Q reductase. It has got FMN as prosthetic group, and it has also got iron circular protein. Then we have of transfer in this case. And second is called as succinyl dehydrogenase complex, also called as succinate OQ reductase. Then we have seen the sequence in this case also. The complex number 3 is called as OQ cytochrome C oxidoreductase. In this also we saw the sequence. Then fifth one is called as cytochrome oxidase, and here also we have seen the sequence of transfer. The fifth complex is oxidase. And we have seen the substrate for NADH is glyceraldehyde 3-phosphate pyruvate isocitrate alpha ketoglutarate malate and beta hydroxyl acyl CoA, and for the substrate of FADH2 it is succinate fatty acyl CoA and mitochondrial glyceraldehyde 3-phosphate. After that, we have seen the diagram of electron transport chain, that how it is transported. So here you can see in the first complex and second complex, the electron are given directly to the complex. In first complex, it is coming from NAD, coming from FADH. Then they both are accepted together by CoQ, and then they are transported to the third complex, and there it is moved to the cytochrome C, and from cytochrome C it is given to the fourth complex, and finally water molecule, it accepts the electron and get converted into water molecule. And now we are going to see the second part of the electron transport chain in our next session. This was the first part. And lastly, as we say, let's crack CSIR UGC NET. Please hit the bell icon for getting all the notifications of the upcoming classes, and hit the like button also if you really like my video. Subscribe our channel if you haven't subscribed till now. And lastly, do not forget to use my referral code FB1 for getting a 10% discount in the plus subscription. Plus subscription can be very much helpful for you for qualifying the examination, because it is in a very systematic, well-designed manner, and you can be able to complete the whole thing in a limited period of time. So this is it for now. If you have any query or doubt related to the topic, you can write in the comment box. Other than that, if you want to read a particular topic by me, you can write in the comment box again that this topic I want to read. So your doubts, your queries, your choice of topic can be written in the comment box. Come back for the next video whenever I am doing the next video. For now, I hope you have understood electron transport chain in a very systematic manner, and now they are in separate compartments in your mind, so that whenever you want to retrieve information, they are always ready and they light up whenever you ask them to give you the information. So this is it for now. Be happy, keep on studying.